there. Didn't see you there.
You must be here for the Sustainable Building Design video presentation. So good job you've come when you have. Ben and Fraser, just getting the beverages. Oh, hi lads.
Hi boys. You must be wanting to find out about our zero energy community and shopping centre as part of our Sustainable Building Design module.
First, let me introduce ourselves. I'm Ben Brown and I'm the contractor. My primary roles were to find out statistics about the local site to help inform our design decisions, as well as choose what materials will be useful for a project with such unique energy requirements.
Hi, I'm Quinn. I'm the architect. I've come up with all the preliminary designs as well as the final design, focusing on how we can create a sustainable form and building and other aspects that are involved in design.
Hi, I'm Matt Cox and I'm the environmental technician. I've been tasked with dealing with different environmental aspects of the build, such as how heat escapes the building and how heat energy can be input into the building at a sustainable level so to sustain quality thermal comfort for the occupants.
And I'm Fraser Foster. I'm the assistant architect and BIM manager. I helped Quinn with different aspects of the final design and recreated on a 3D BIM model.
But I bet you're asking yourselves, what exactly is this project we're working on? What have we been tasked with doing?
Well, funnily enough, we have been tasked with creating a shopping and community centre with a zero energy system.
This basically means that the building's energy input is the same as the building's energy output, meaning there is no difference in energy, a zero net energy system.
This is due to the government wanting to reduce CO2 emissions, otherwise we could lead ourselves to an inevitable doom that we will never be able to recover from. So we need to start being more sustainable in how we design and build.
So in order to combat this, we have created a building that's not only environmentally friendly, but also has many net zero energy design features, uses no form of mechanical cooling, and most importantly, has an annual net zero energy consumption.
So fellas, where do we begin?
Well boys, I know just the place. To the planning room. But first,
Right, so we had to choose a design process in order to decide how we go around designing our building, which we decided to use a user-centered design.
So this is a 4-step process of plan, analyse, design and refine. The first step, plan. What we need to do is we need to get everybody together in order to outline the main specifications of the project. The first is we need it to be a zero carbon energy building. The second is we can't take up more than a third of the footprint of the site. And so when we're together, we will meet up and we'll discuss how we can meet these set specifications and points.
Stage 2 is analyse. This is to see how our initial ideas have met these points and to what extent they've met the points. If there's room for improvement, then we should do some extra research. For example, on the environmental data of the site, whether the way the sun shines on the site, precipitation, windfall, all can be used to our advantage to lower the carbon footprint of the building.
From there, we then move on to the design stage. We take the data that we have collected and attempt to make a compatible design with said collected data so that we can produce a fully energy efficient building to our prior study.
Then finally, the 4th stage, refine. So we check the design to see if everything works efficiently and effectively, and if not, we can alter the design slightly to make it as effective as possible.
Well, now we're all wrapped up, let's go visit the site.
Ah, here we are. This is the proposed site, situated next to Allendale Road, Loughborough. Now in the southwest section of the site is where we plan to situate our community and shopping centre.
To fit in with our analysis section, I did some environmental research on our site to give us the information we needed to help us influence our design. Loughborough is experiencing a lot of strong winds, and this is exemplified with the rest of our area, as you can see. The winds predominantly come from the southwest direction, reaching speeds of around an average of 12 miles an hour. Very typical for the UK. Now on to sunlight. Loughborough is typical for a town in the East Midlands, receiving the most sunlight during June and July, an average sunlight factor of 8 hours a day. However, in December and January, Loughborough receives only on average 1 hour of sunlight a day. This means for our design we shall have to worry less about heating and lighting in summer due to the solar gains, but have to worry about it more during winter months. Loughborough is very typical for the UK in terms of rainfall. It's pretty rainy. On a rainy day, Loughborough receives on average 60 to 80 millimetres of rainfall. These rainy days are very common during the December, January and February months, and therefore we shall have to design around them. Right then boys, we're off to the lab.
Right then Fraser, we'll go to the drawing room.
Yeah.
So, there are different things to take into account when supplying energy to our building, such as light, heat, wind, materials and their U values. We decided upon using ground source heat pumps to heat our building, using heat absorbed from the ground. Now, given that the temperature at the chosen depth stays fairly steady, we can use this system throughout the year. We plan to place most of our daylight openings on the south and north faces of the building, as the sun rises and sets in the east and west respectively. Innovative and advanced window technology will be utilised to provide different tint levels on certain windows to improve the daylight comfort for the occupants as well as the thermal comfort. Finally, the building's most occupied rooms will be ventilated best to provide the occupants with the best possible thermal comfort. And we will also be utilising stacks so that we can draw air through deep spaces where cross-ventilation may not be possible.
For a project with environmentally minded brief white hours, we knew it would be destined to search for good materials. One of the best ways to reduce the heating load in a building is to have low U values in the construction. A normal house brick walls have U values around 2 and windows between 2.5 and 3.5. However, this is nowhere near good enough for our project, so we look towards the passive house requirements of 0.15 and 0.85 respectively. We choose a combination of Airlight standard thermal and Insulite structural concrete blocks produced by Thomas Armstrong, the manufacturer of the blocks with the lowest U values across the UK. So we use these in conjunction with polyurethane insulation panels, glass fibre board, and also the internal external finishes to make up our walls. The outer face structural block work should be 50mm thick, with a U value of 0.42. Inside that will be 2 layers of polystyrene insulation of 75mm thickness, with a U value of 0.025. These shall be encapsulating a layer of 0.25 U value 10mm thick foam glass, and finally on the inside, thermal block work of 50mm. This gives the walls a total combined U value of 0.15.
Well, I guess that means it's up to Quinn and Fraser to go through the design.
Pub?
Pub.
Ah, lovely, good stuff. Because I'm the architect, we came up with a lot of the preliminary designs which have led us towards our final design, and we're going to talk you through them here.
We also then put the final design onto a BIM model so that you can then see through everything in a 3D fashion. So this building we called triangulated simply because it has a triangulated shape. We then recreated it on 3D BIM as you see it now. We have 3 main bodies to the building: the south face, northeast face, and the northwest face. Also with the car park attached next to it. And then a loading bay around the back to the northeast face as well. We designed the south face along here to be the longest side. Therefore, we get more sunlight hitting it due to a larger surface area, which we fully use to our advantage, such as placing PV solar panels along here. Therefore, by getting a large amount of sunlight hitting it, we can then gain a lot of energy from it, such as converting it to electricity. We decided to add curtain walls along the south side. Therefore, there's a lot of natural light entering the building, so there's little need for artificial light during the day.
That's it, thank you very much.
We hope you enjoyed, and if there's any questions you'd like to ask, feel more than free to ask them now.
Now, let's go join Matt and Ben at the pub.
Let's do it.
Oh, can't teleport anymore.
It's because the end of the video, isn't it?
Let's go, youth.